Well, hello, this is Gary Taylor. I wanted to cover MassTransit Platform today. I want to talk about what platform is and what problem it's trying to solve. I'm going to go into a demo, but I'm also going to extend that demo a little bit. Let's dig a little bit deeper. Let's try to turn this into a real boy. So, without any further ado, let's get started. Okay, let's head over to Chat GPT because nobody seems to write their own code anymore, do they? And let's work out how to configure services in .NET Core. So we all know that when we're configuring services, we've got to register dependency injection, we've got to include these services. And these services normally have some kind of configuration like use mass transit or use DB. So we can configure services by using a service.add. And you can say whether you want them to be transient, whether you want them to be a singleton, and things like that. So this is pretty much how you can actually configure a service and register it and then use dependency inject it to inject it into, one of your components that you want to use. Now this is great, but over time that builds up. So, here's an example of someone talking about that.
And then you can decide which one you want to use in your own application. I'm inside of program.cs of a .NET 7 web API, and you can see I have a lot of code for configuring services inside of it. We are configuring Redis, then adding some of our own services. We are adding Mediator, the database context, some background jobs. We're also adding authentication and authorization services. And you can see we have close to 100 lines of code for configuring our services.
So let's have a look at mass transit. So of course, mass transit comes with a lot of dependency injection built in, as we know. But in order to get it configured, we need to be able to configure the bus. We need to be able to tell it to use mass transit. We need to be able to tell it what the host, username and password is. We need to be able to register consumers. And these are just the basic primitives. Now, of course, at the moment, we have got a host name and it's localhost, but that's not the way it is in production, of course. We need to be able to change that. So how do we change the host? So of course we've got to use the host method and we've got to pass in values. Now that's normally done using some kind of config, whether it's an environmental variable or something. So of course you need to make sure that your config is configured by that point. So, if we want to use an environmental variable now, we've also got to register the configuration agent. We've got to make sure that we've got the correct variables. We've called it host UI, but we've got to make sure that that's consistent across services and everything that we use. Because of course, with microservices, it's distributed. We may end up having hundreds or even thousands of these services with this exact same boilerplate code within it. And this isn't a great example because this is using environment.getEnvironment, but really we should be using config. If I could spell. So now we've got to look about injecting our configuration, maybe our options. We've got to start looking at whether we need to pull data in from environmental variables or from app settings or app config. And this is something a team will try and get some kind of commonality. The team need to agree on what this looks like. But here we can see now we're injecting the iConfiguration. So what we can do now is use iConfiguration and use a variable called host URI, which will then be injected in. But guess what? That is just one of many, many settings that you might want to configure. So, one of them is a retry policy. How many times should we retry? And of course, that is configurable, and it's something that a team will decide upon. Some people would be happy with a retry every second because the network is so quick. Any kind of timeout problem doesn't need to be that have much of a delay. Other people know that their systems need more of a delay, so like an intermittent delay, try in 5 seconds, then 15 seconds, then 30 seconds. So all of that needs to be configured within the application. Now that's great if you've got one application and you're only going to release that one application, you put all your configuration in there and everything's great, right? However, in distributed environments, what you've got is Monday morning, your team starts a new sprint and straight away file new project. And instantly they've got to start copying and pasting all of this boilerplate code across into this new project. And it's typically done by opening the latest project that you last worked on, the last good known state, which means that you've got this craziness of being able to see how every system's evolved over time and how the team has adapted, because every time a new project is created, it's getting better. Now, that's a good thing, of course, that's adaptation. But all them previous solutions and projects are still running in the old way. So if we decide now we want a retry policy of 5, but we only want to, we want to ignore some kind of errors, for instance, truncation errors, then we've got to go back retrospectively and add that configuration to all of them apps, test them, compile them, release them, and get them out into UAT staging and production. And the truth is that doesn't happen. These old apps just remain old. And in smaller teams that can't afford that kind of refactoring work, they just get bit rot and get left to go stale. So let's see if we can work out how to add an ignore policy. So once again, this is more configuration that you could add. You might decide truncation problems. Well, there's really no point in retrying when it's a truncation problem, because if that is too long to fit into the database, it doesn't matter how many times you retry, it isn't going to work. So you can put in retry policies and you can say that, certain exceptions, will not be retried. That's great for the one app that you're currently in the middle of deploying, but for the other 99 apps that are currently out in production, they haven't got that latest code. So Platform is designed to try and centralize all of this configuration into one central place. But I know a lot of people will be shouting, saying, well, that already exists. We've got NuGets, we've got shared libraries, we've got common components. We can do it that way. What makes MassTransit Platform different? Okay, let's head over to the documentation, shall we, and have a quick look through. We can see that we have a section here called Platform, and there's a couple of examples of how to get this up and running. But what I want to do is dive over to GitHub, where he's thankfully created just a sample platform project. So what I want to do now is take this code and let's clone this. So now we've got sample platform. Should be able to work with this. Let's open this using our favorite IDE. And it says that we should cd into the source directory. And of course, there's a sample platform example in there. We just do docker compose up. Compose, let's build, no cache. I know it doesn't say to do that, but that's something I'll always do. It might have the image already from when I've been playing about with this. So a couple of seconds, that's going to be built, and then I can docker compose up this. So I got rid of an old image that I had floating around, and we can see that this is now coming to life. So let's have a look around. We've got obviously the README file. Let's have a look at the compose file if we can find that. So the Docker compose file allows us to have Rabbit up and running. Of course, there's a couple of different broker systems that MassTransit supports, but Rabbit seems to be very common. So we've got this Rabbit server that we're getting up. It's MassTransit Rabbit, so it comes with a lot of configuration that's already set up to be best of breed. Things like scheduling and things like that are configured within it. We enable the ports. And then we have a service, which is the sample platform. This is connected then to this network and exposed on port 5000. So let's head on and have a look at this. We can see there is a consumer. It's going to take a sample consumer. What's it going to take? A sample command. And it's just going to output something, a log to the system. Now, the interesting thing to know is there's no startup and there's no program file. There is a sample startup. And what's happening here is that there is an iPlatform startup interface that this implements. And when the system first fires up, it tries to find an instance of this interface, an implementation of it. And it'll scan the code using reflection, take this interface, run this configuration, and get this consumer up and running. Now that means that there is no configuration. There's no setup. You just need to register your consumers that you want and any services that you need that are custom to this piece of software, this particular project. But as for all the other things I discussed about like retry policies and things like that, of course you can extend them here and customize them. But your standard boilerplate configuration that your team has agreed upon and discussed and spent months and months improving upon is in a different location. It's stored somewhere else, somewhere centrally, which means that every time we build a new project, we can just start straight away with our consumer, configure it, set up the startup, iPlatform startup, and just make sure that we've registered our consumers. And that's it. There is no more configuration to be done. I don't need configuration for iLog or iCommand or any of the other services that I deem I need, like maybe you've got a logging system like Datadog or something like that. None of that needs to be, you don't need to worry about that when you're building your apps. All of that is now handled for you. But how is the question. If we look at the Docker file, we can actually see that the Docker file, we are taking our code and we can improve upon this, but we can take our code, we can build it, we can publish it. But notice that we are not running the builder, nor do we have a release image. What we're actually doing is using a MassTransit Platform image to run our code. So that means that this image, MassTransit Platform, is the thing that configures everything, bootstraps the application, and then looks through this source directory for some code that implements the iPlatform startup. And it takes this and it registers all of the requirements and all the dependencies automatically. Now, this is magic. This application is written and it's doing reflection to scan through code. It's got all the configuration in there. But it means now that all of the configuration for how you want your systems to be configured and set up are now within this Docker image. I really like that idea. That is the thing that really screams out me. It's not a NuGet package. It's not another project that's been referenced within the startup project file. This is super clean. We're only accessing the abstraction platform. This is the thing that will make it understand what this iContract is. And that's the only thing we need. Now, because of that, we are able to create a command, create a consumer, register it using this startup, and that is the only code in our project. The Docker file will take our code, compile it, push it into a folder, and then tell MassTransit Platform to look in that folder and say, go and have a look. See if there's a startup. See if there are any consumers in there. Wire them together for me. Put logging in, put configuration in, put dependency injection in, all the things that we've discussed as a team. You know, if there's a truncation problem with SQL or some other DAL, then ignore that. Don't have a retry policy. And for all network connections, make it 1 second, 5 seconds, 30 seconds. Now, instantly, every single app has the ability to take in that configuration. The pièce de resistance to this, if that's not good enough, is that when we now deploy this app, we are instantly going to get the latest. I would personally recommend Simver in this, version controlling it and having a min-max version. But for small teams and people who really trust this platform as a service, which everyone should trust platform, right? We can pull in that latest image and instantly get access to the latest configuration. Let's say platform team and error teams have discovered that there's a particular bug and there's a retry that's making things worse. And there's a retry hitting a service. And we now know that when that service is down, it's down for 15 minutes. And in it's an external system, we can't do anything about it. The retry policy just makes it worse because we're increasing the amount of network traffic that's happening. And there's no circuit breaker pattern on this, so at the moment it's making it worse. To make it even harder, there's 10 instances of this, which means that there's actually 30 requests going on, well, 27, which are completely pointless. So for that reason, what we can do is the platform team will update this and say, we will put a retry policy in there, and we'll say, for a particular endpoint, we're not going to retry. The HTTP client is just simply not going to do it. And the HTTP client is configured within this MassTransit platform, within maybe your own platform system. Instantly, then all we need to do now is build and deploy to UAT and staging and production the apps. We don't need to change them. We just need to now build this new Docker image, which can be done from pipelines. And a platform team can just simply press that button. No developers required. Press the button, builds using the latest package, image. We then run our integration tests, unit tests, end-to-end tests, and some staging and manual tests through UAT staging, and then it's ready to go into production. That allows us to release these things instantly without taking the developer team time and effort to actually go back and refactor code. Now, this example is great. We have got a Docker Compose file that's going to give us RabbitMQ. It's going to register a consumer, and it's going to sit there waiting for a message to come in. However, that's never going to happen because there's no publisher in this sample project. There's nothing that's actually raising via a send or a publish any message that will be consumed by this. There's also no way of actually writing code and testing this because, of course, this project doesn't run because it's a class library with no startup and no program file, so it can't run. There are also no tests that are using this. And as I said before, there's no publisher. So although this is a great sample and shows you how clean a consumer could be, I don't feel it's good enough to actually ever go into something in production. So next, I just want to go through and show you a working example. This isn't something that's perfect, nothing is. But I want to show you something that's just got a little bit more meat on the bone to actually show how this works. Okay, let's discuss this sample platform, but with a little bit more meat on the bone. What we're going to do here is actually show you a project that I've put together, which is just a copy and paste or a clone from the original sample project, but I've added a producer on it. so that it'll actually start sending messages. And you can see I've just been testing this now. So if I do a Docker Compose up, we can see that it'll do exactly the same thing. It's going to start up Rabbit. It's going to start up a consumer, but it's also got a built-in producer. And the built-in producer will just run every couple of seconds, and every second it'll send a message out, which is really primitive and really simple, but it means that you can actually test that this is hooked up end to end. All we need to do is do a Docker Compose up, and your development team knows that Rabbit's integrated, that the consumer's integrated, and that messages are going backwards and forwards between you and your message broker. So let's stop this and let's have a quick look at what's happening here. We have sample platform, which just has a sample consumer, and this is the one that we saw in the previous example. Nothing special about this. We can see that consuming something on, you can see they're consuming something on. So when a message is sent, it's picked up by this consumer here, and anything that implements this sample command is then going to get consumed, and then we're going to log this out. But what is it that's actually raising this event? Well, this is a new thing that I've created just for testing this, where we have a worker that is just going to loop through and it's just going to send a message. So it's going to take sample platform contract, sample command, and it's going to send the date. And we can see that here. We can see the date actually being outputted as a log here, and that's because it's been published there. Now, if we head over to the program, this program is very simple. Creating a host, creates a worker, runs the worker. So what we're able to do here is have this worker, which is just implementing background service. This is just typical .NET Core code, connects up and sends a message, we'll either send or publish. In this scenario, I've just used publish because I know I've only got one consumer listening and I didn't need to wire up the send correlation. Now, what I want to do is show you another example of a worker. It's just got a bit more meat on the bone. And if I do Docker Compose build, you should see that there's a change there. It'll build it. And of course, I get the new image. So when I do Docker Compose up, it's going to run the new image, which will now use this school worker. And we should hopefully see messages coming in as we can see that administrators have been added to a school. And then what we're going to do is do a search to see if a particular person is an administrator. I'll explain this a bit more in detail in a second. But what I've done here is I've actually just used a different worker. And this worker has some endpoints convention for using send, to create a school, create admin, and to search. And this producer is just working through, it's going to use some faker. So it's going to be able to randomly select names. It's going to send them to this consumer, and that consumer is going to process it and process these messages. And we can see that because these messages have been received, and we can see that data is then trickling back. So let's stop this and we'll go into more detail about what this is. Now, of course, I have got a different consumer. And what I wanted to do was set up a school search system. And if we have a look at the unit test, which I'll go into more detail in a second, but if we have a look at the DSL for this, so the problem that this consumer is trying to solve is there's a prestigious school, there's a number of administrators, variables, and your program should ask for a user. And if the user is an administrator, they should get a special greeting. So, if there's an administrator called Michael, if you then type in that you are Michael, you should get a special welcome. But if you're not an administrator, you should just get a general greeting. And that's the problem that we've solved within this consumer. So we have a look at the school search consumer, I'm not going to go through the logic of the code. That's irrelevant here. But what I'm going to do is show you that we are raising these events and we are consuming these events, and we are going to do something with the data. Now, in the sample platform, once again, there is no program, there is no startup, there is no boilerplate code for configuring this consumer. I'm not saying how to connect to MassTransit. I'm not saying how to connect to RabbitMQ. I'm not saying what the retry policies are. I'm not saying how to ignore. I'm not saying how to log. All of this is just configured outside within the platform, as we discussed before. So all I need to do is work out how to solve the problem. As a developer, how am I going to solve this problem that's been given to me about this school? Now, a very common thing for developers to do is to just hit run, start this, and start debugging it and solving that problem. What I would like people to start thinking about is to do test-driven development, where you start off with a test. And in this scenario, you will start off with a test and you'll try and give it some decent work. And don't worry, this is not a talk about TDD or anything like that. But what I'm doing is I'm explaining that I was able to build, code, compile, and test this without needing to have a program that was runnable. I just needed to have this unit test framework. In here, I have got the logic. Given we've got a school, say for instance, St. Trinity, if we've got an administrator called Alexandra and one called Bob, then if we search for Alex, then we shouldn't get the special. The special should be false. We should get the general greeting, as per the spec I just said before. And on the flip side, if we have Alexandra, Bob, and John, and we are Bob, then we should get the special greeting. It should be true that we get it, and it should be false that we don't. Now, that was the spec of the test, right? If a person's an administrator and they're an administrator, give them the special greeting, otherwise don't. We're able to test this code now really easily. And what we've done is we've placed the workings of the code, the GUI. How does it actually do it? Because this all looks very English. All of this has been placed into what's called a DSL layer, which allows us to place all of the actual workings of how it does the job. So here we can see in this test, we're creating a provider. We're going to register the consumers that we need to be able to perform this operation. And we're going to build a test harness. And this test harness is an in-memory MassTransit consumer or broker, if you like. It's not using Rabbit. It's not using, any other platform, all in memory. And we can go through this and we can create, given we have a school, well, this is how we create a school. We create I create school, and we will get a school back. We pass it the school name and we will get a school coming back. And notice that this actually returns the data from the consumer, which is really handy because we do need to know what the school is. And if there is an ID created, we're going to need to know the ID of that newly created school. And if we have an administrator, so this creates an admin for that school. So now all I need to do is pass in the school that I want to add an administrator to, because I've allowed this system to support multiple schools, and it will pass it in, and that will just add the admin. So we can then search, so we can use an iSchool search contract, and we can do that. We can work out whether the person exists in that school. We don't need to return any data, because the good thing about this iSchool search is that the consumer is going to raise an event. So if we look at the implementation of this, hopefully we can quickly dive into the consumer, sorry. So here we're consuming this. If we found that the person is in fact an admin, we're going to send out a special greeting. Otherwise, we're going to send out the standard as per the spec of the test. So let's go back to that when searched. Now, All I've done is created some pretty names and an easier contract of how to access this within tests. But the great thing is now I'm able to run these unit tests and test that everything works. I can extend these unit tests now to create different names. So for instance, I could create something to see if it's case sensitive. I'm just going to give this a quick run, go up and run this, and we can see that my tests are passing, which is great. So let's try and copy this fact. And of course, we would never do that. You would use some special kind of gherkin or something. But for now, we can paste this in. And I'm just going to do a check to see whether this is case sensitive, because I've been told by my product owner that it shouldn't be. So I'm just going to give this test a better name. I would normally write at the top as well the actual story. So I'm going to add Bob, but I'm going to search for Bob. And if I run this, we should pass because my product owner's told me that it shouldn't be case sensitive. But it fails. So that means that there's a bug in my code. It's checking for sensitivity. So I'm just going to go and fix that just by making sure the assertion isn't bothered about case. So if I actually go into the DSL, I can actually work out what is being sent. I can see that it's iSchool search. Let's dive into there and look at the implementation. There's a consumer here. Right, okay. And I should be saying found equals that. So ChatGPT appears to be off, which is deadly because that means I'm going to have to program myself. No one wants to do that. Oh, there we go, should be back up. When using link, how do I use a case insensitive filter? So there's a string compare where I can pass in a parameter, hopefully, that will make sure that it's not going to check and test for uppercase and lowercase. So we just put that on the end with the looks of it. So let's copy and paste that because, like I say, no one writes code anymore. If you're using link to SQL, you might need to use a different method to perform case insensitive comparisons. Let's give that a go and let's see what we win. Okay, so that's failing. This is not a test. This is not a video about coding. So you learn something new every day. So could use a like. That feels a bit wrong because like will search for a beginning of something or an end of something, not an actual comparison. But yeah, we can do to lower on it, which I think probably would be a little bit safer. However, I also don't like to lower because what you're doing is you're actually going through and you're lowering it. But for the sake of this video, which is not about how to make a good SQL, I'm going to do that. I've updated this so that I've got to lower. I do not like doing this. I would never do this in production. And we're saying that this equals the search name to lower, and now I'm running my tests, and indeed all my tests pass, including the test now for Bob being lowercase Bob. And of course, we should really do the mismatch so that Bob there is lowercase and that is uppercase, just to guarantee that the tests are working the way, and to make like the inner A uppercase and a D uppercase just to make sure. But for now, this is more than good enough just to satisfy my product owner, and off it can go into staging and stuff. So what I've done is I've demonstrated here that even though we cannot run the sample platform, even though there's no startup and program, we never should do. We really should be working with tests. And now that we've got this test, we can make sure that we are passing what their product owners and product managers are asking us to do, and we are hitting this contract, and everything should be good. But of course, life isn't always that easy. What we're doing here when we look actually behind the scenes is that we are actually setting up a lot of this within a fake or within a in-memory system. So we're registering our consumers here, but guess what? They're not actually registered in the producer or the consumer. We might have missed that. So we need to do a little bit more. And what I love to do is I love to create a producer that works like business as usual. So if your business is doing this 20 times a day, someone searches, well, do it 200 times. Get this to work 200 times every hour. Make it go and automatically do these steps. So what I've got is a producer that's a worker, and it's going to act like our business as usual. It's going to act and pretend that it's users of your system. It's going to loop. It's going to create a school. It's going to get a random name using the faker. You can use whatever faker library you want. It will then create a school with that name. It will then create a series of random admins using faker once again to get the first name. And then it's going to send the messages out to create the admin. It's then going to do a search. And all we need to do is monitor the search results within Rabbit to make sure that the general message that was sent out was obviously for the people who are general, and the special messages were sent out for people who were actually an admin of that. So let's have a look at that in reality. Let's see if I can run this. So I'm going to do Docker compose up. It's going to start running this worker. It's going to create a school. It's then, so let's have a look. We've got a faker. We're going to create a school here. Now that we've got the school, we'll have the school ID. So we can now start sending some admins. So we can create an admin. You can see the admin is going to use the school ID of the new school that we just created. And then hopefully, we are going to search the admin using the iSchool search interface. And we're going to wait for a couple of seconds. Now, this is where we can determine what business as usual looks like. I would always recommend timesing by 10. So if there are 100, if there are 10, you should do 100 every hour. And that would allow you to create a staging or a UAT environment that could simulate real traffic. And because this is using Faker, you can see that the data is changing each time. Now, this will catch some obvious errors. This will catch the fact that maybe a particular endpoint wasn't registered. You know, if I'd forgotten to wire up iCreate admin, then it would error and we would start seeing some problems there. So if we look at our sample, and of course that's got to be within the consumer, this is firing, and if we'd forgotten to wire it up, then we would see problems, but we haven't. We've been able to successfully do it by adding everything from the namespace, so we can see that it's actually being wired up correctly and it is working. So that's good. And we can prove that by knowing that all of the interfaces that needed to be exposed, all the results that needed to come back, are actually visible. We find our way over to RabbitMQ. we can actually see messages being processed in RabbitMQ. We can see that there are two connections from this, one from the producer and one from the consumer. We can see the channels and the operations that are happening. We can then see the exchanges themselves, and we can see data trickling in through the exchanges. We can see that, I special greeting and I standard greetings are using a publish because they're using this naming convention. So we can see that they will be published out, which is kind of what we want for a greeting and a type of event. But we can see now here that there's send actions happening for create admin, create school, and school search, and they correlate to our interfaces that we have. Of course, there's nothing using publish for these types, so we see there's no actual traffic going through. So it's a really nice way of being able to see what exchanges are being used based on what type of mechanics you're using, whether you're using send or publish. And of course, if we look at the queues themselves, we can see that data is trickling through. This special queue here is obviously, well, not obvious, it's actually a response object. It's returning data back to the publisher. In other words, when I create a school, I really need to know what the school ID is, because without it, I'm not able to then create an admin because I don't know the ID of the school that the admin belongs to. So this is actually returning back that object. If all of this was wired up to something like Datadog or some other kind of telemetry, we could see and be able to visualize all of this data running through this system. Now, at the moment, this is all in a UAT environment, but it means that the essence of how this should work, if this was to work well and business as usual, this is what it would look like. And that means that we've done a quick sanity check as developers to say, look, I feel all of this is wired up great. I'm getting no errors. My tests are passing. Everything's wired up. Even when I run this in Docker Compose and everything starts running as one, other things that other developers have been working on, they all seem to be working great as well. Well, now this can be handed off to, or well, not handed off, but now you can start looking at testing this, doing some more edge cases. What happens if you put a school with 1,000 characters in? What happens if you put special characters within the search? Does O'Brien with apostrophes work in the search? Them type of things. You can start testing the edges and working this. And then, of course, find its way into staging and production. And I just showed you how easy it was for me to actually build and test that. And I was able to do that just within unit tests. I didn't need to run anything. I didn't need to worry about any particular aspect of this. I was just able to run my test, confirm that the operation for the one thing that I was responsible for, my product owner asked me about case sensitivity for search. So that's all I need to care about. I don't need to care about getting RabbitMQ up and running. I don't need to care about the producers and consumers. And as systems get bigger and bigger, unfortunately, they get more complex and more systems will use these contracts. There might be 4 or 5 people who are trying to use an iSchool search. There might be 100 external systems using it. Well, at that point, I don't need to care. I didn't change the contract. I didn't change this one central source of truth, which is iSchool search. I was able to actually keep this exactly the same. Now, because of that, there are no breaking changes. My tests were clean and independent, which is kind of one of the best things about doing event-driven architecture, especially with MassTransit. I just love the fact that we can test and build these things and know that I'm not going to hurt anyone because I have not changed the interface. So this is a bit more of the project. You can see this on my GitHub. It's in no way perfect, but I think it will actually go to demonstrate and explain how you can actually make this a little bit more concrete within when you're actually developing and coding and testing and building. A lot of these examples and a lot of the things that you'll see are just, oh, how to do this one thing. But the nature of this video, I hope, will show you how to actually really develop this and turn something into a real boy. This is very close to production ready. Um, I can do some performance testing on this, and I can make sure that the SQL query that is being produced is fit for purpose. I can clean this code up, but none of that's got absolutely anything to do with the actual functionality of what this provides. My product owner asked it to be case insensitive. Well, I've done that. When this is in production, I can then monitor to see whether it can be optimized. I can actually see how quick these individual requests are being processed. And as this happens in staging, where there is a good quantity of data that mimics production, I can see whether that query needs to be optimized. But at the moment, I was just able to quickly go in, resolve a feature bug or a defect, and actually get that out into staging or UAT within a couple of minutes. Because all I need to do now is commit this code, push it up, and these images will be built and pushed out to our environment. Of course, not everyone's using Docker Compose. Some people are using Kubernetes and things like that. So you might have like a mini cube or something set up. So what I've done is I've created just a basic scaffold that allows you to get Kubernetes up and running pretty quickly. So what you should be able to do is just use scaffold dev to build this project. It's going to do exactly the same thing. It's going to build the sample platform and the platform, and it's going to get Rabbit up and running as well for you. So with this in mind, you run that, it will get Rabbit up. The consumers start a little bit too quick. They have to wait a little, let their horses. Right now they're okay, they're connected. And now you can see that you can creating schools, and all of this is now running on a Kubernetes engine. So it's incredibly easy. One of the best things I think about doing this from Kubernetes and Scaffold is your ability to actually be able to quickly make changes. However, I think that goes against the test-driven development. So what I mean by that is if we look at, let's say, create school consumer. Let's just bear with me one sec, actually. Let's have a look at the producer. So we can see school worker. We can see creating school, searching for admin. So searching. So we've got one called searching school for admin somewhere. Shout if you spot it. Of course, it's in the consumer. Silly me. So if I do that and save, what we should be able to do is rebuild and redeploy that to a new pod. We're going to decommission the old pod. We're going to build this new image, and we're going to create it, push it out as a new pod, and just wire everything back up automatically. So we can now see searching for school, and we've got the two semicolons in there that I've just put in, and of course that's ridiculous to put in, so I'm going to take them out, and it'll detect the change. It'll know that it's dirty. It's going to decommission the old pod, create a new image by compiling it and pushing it out. Although this is very, very cool, I highly recommend that this is not the way you develop code. It's fine for a one-off tweak. It's fine for a little change, but please use the tests to actually build, develop, and test your code, and only use this type of system for making sure that business as usual, and making sure that it does a sanity check of all of the things before you then push it to push your code up, and that then gets consumed and put into CI/CD. I hope you like this content. If you want more like this, remember, click that subscribe button. And also, if you thought this was really useful, please hit that like. Remember, I'm always free to answer any questions, so please drop them in the comments.